Hello everyone, welcome back to our channel. In this video, we will study about the particle nature of electromagnetic radiations. In our last video, we have studied about the first nature, that is wave nature of electromagnetic radiations and the wave parameters associated with the electromagnetic radiation. Okay, we have some of the phenomena, light phenomena like reflection, refraction, diffraction and interference. These all can be best explained on the basis of wave nature. But still we have some of the phenomena like black body radiation, photoelectric effect and line spectra of atoms. These could not be explained on the basis of wave nature of electromagnetic radiations. But then how this can be explained? This can be explained on the basis of particle nature. If we consider the electromagnetic radiations as particles, then only we can explain these phenomena. What are those? Black body radiation, photoelectric effect and line spectrum. We will study about these phenomena first, then we will move on to the particle nature, means how the particle nature of the electromagnetic radiations will be exhibited. Okay, the first phenomenon is black body radiation. What do you mean by black body radiation? You just take a metal, any of the metal you take, and you start to heat that metal. Whenever we start heating any metal, for example you take iron only, okay, iron rod, and you start to heat that metal. Initially what will be the color of that iron rod? That will be dull red color. Initially it is dull red color. Okay, it is, you are just started heating that iron rod. Okay, it will be in dull red color. You will get dark red if you go on increasing the temperature. Here, from here to here you are increasing the temperature, and again if you heat it continuously, it gives white color. It gives white color radiation. White color radiation. Again at the last point, at the highest degrees of temperature, it gives blue color radiation. It gives blue color radiations. Okay. Here what happened? You started with the dull red color and you ended by getting blue color. Here what happened? On heating that iron rod, you got different radiations, different colored radiations, and these different color radiations will have different wavelengths and frequencies. And what is about the frequency? As you go on increasing the temperature, the frequency also increases, because the dull red color has less frequency than the blue color. So what happened here? As we go on increasing the temperature, the frequency also increased, and this body or this iron rod, when we started heating, it started giving the different colored radiations. These are nothing but different colored radiations, right? What do you mean by black body? An ideal body which emits or absorbs radiations of all wavelengths is black body, and the radiations emitted by that object are called as black body radiations. Planck he said that these atoms or molecules emit the radiations in the form of discrete quantities. In the form of discrete quantities. You take atoms or molecules. Atoms or molecules, they emit radiations in the form of discrete quantities, and he named these discrete quantities as quantum. What he named? He named these discrete quantities as quantums. Okay, quantum is the name which is given to the discrete quantities of energies by the scientist Planck, and energy of these quantum are directly proportional to the frequency, as we have seen here, right? If when we go on increasing the temperature, means we are increasing the energy, right? When we are increasing the temperature, we got blue color. At the last we got blue color at higher temperature, means at higher temperature blue color is of higher frequency. So what is that? Energy of these quantums are directly proportional to the frequency. E is directly proportional to the frequency. This is the symbol for frequency. So what is this H? H is the proportionality constant. H is proportionality constant. So this is the relation between energy and frequency. Energy is directly proportional to the frequency. Energy of the quantums directly proportional to the frequency. As the if we go on increasing the temperature, the frequency also increase. So whenever the energy is high, then frequency of that radiation is also high. Okay, this is about the black body radiations. And the second one is photoelectric effect. The second phenomenon is photoelectric effect. What do you mean by photoelectric effect? And this experiment was done by the scientist Hertz. Who is that? Hertz. He did this photoelectric effect experiment. What he did? In photoelectric effect, what happens? That is, emission or ejection of electrons takes place from the metal surface. Ejection of electrons from the metal surface whenever that metal is exposed to radiations or light beam. The process of emission of electrons from the metal surface is known as photoelectric effect. You take this as a metal plate. Okay, it is a metal plate, and whenever this is a radiation or a beam of light. Okay, when this beam of light it hits this metal surface, what happens here? Electrons from this metal surface starts coming out, or they starts ejecting out from this metal surface. So these are the electrons starts coming out from this metal surface. This phenomenon of ejection of electrons when the metal surface is exposed to beam of lights, or these are radiations. And this phenomenon is called as photoelectric effect. Okay, this is simple thing. And when he observed this emission of electrons or the ejection of electrons, he drawn some of the observations on the basis of this experiment. Those are, the first observation did by this scientist is, there is no time lag between the emission of electrons and the striking of these radiations. Means, as soon as the radiation strikes this metal surface, the emission of electrons takes place. There is no time lag between the striking of this radiation and the emission of this electron. And the second observation is, number of electrons ejected are directly proportional to the intensity or brightness of the radiation. Whatever, if the radiation is very much, intensity of the radiation is very much high, then the number of electrons emission is also very high. If the intensity is low, then the number of electrons ejected are also low. So number of electrons and the intensity are directly proportional. And the third one is, every metal surface, whatever the metal surface we take and which is subjected for this radiations, no, those all metal surfaces have the minimum frequency range. Okay, those all have their particular frequency ranges. Above that frequency range, if we apply any radiations, then only the ejection of electrons takes place, and below that radiations photoelectric effect is not observed. and that particular frequency range on above which the photoelectric effect takes place, that frequency range is called as threshold frequency. What is that? Threshold frequency. Above this frequency only, if we give the radiations, then only the photoelectric effect is possible. Below this frequency, photoelectric effect is not possible, and this threshold frequency is different for different metals. This is about the photoelectric effect. We studied about the two phenomena. Those are, one is black body radiation and the second one is photoelectric effect, and these were best explained if we consider the electromagnetic radiations as particles only. If we consider them as waves, then we can't explain these two phenomena. So now the scientists got into confusion that some of the phenomena are explained on the basis of waves, and some can't be explained on the basis of waves. Be best understood if we consider them as particles, and if we consider it as wave only, then we can't explain these two phenomena. Came to a conclusion that electromagnetic radiations exist in two forms, and they have two natures. First one is wave nature and the second one is particle nature. So whenever the electromagnetic radiation is in motion, it travels in the form of wave. Okay, so whenever that electromagnetic radiation interacts with any of the matter, okay, whenever electromagnetic radiation interacts with matter, what happens there? Their emission of radiation also happens, or absorption. Both may not occur at the same time, but emission or absorption are seen when electromagnetic radiations interact with matter. So these emission and absorption of radiations happen in the form of particle nature, not in the form of wave nature. So what we got to know, that wave has dual nature, that is electromagnetic radiation has dual nature, that is wave and particle nature. One is when it is traveling, and one exists when it is interacting with the matter. Okay, this is about the particle nature of electromagnetic radiations. And when the electromagnetic radiations hit the matter, there they emit the radiation, and those radiations will be in the form of discrete quantities or discrete units, and those are called as quantum, which we have already seen in black body radiation. Okay, these are the points about the particle nature. I hope you all got to know that how particle nature exists for electromagnetic radiations. Okay, if you have any doubts, you can ask me in the comment section. Have a nice day. Bye.